Okay, so rather than trying to use some data set downloaded from websites, I'm going to use a data set that's inside the scikit-learn. So to do that, we will first import the standard packages. Matplotlib, and then to load the iris dataset, we're going to do from scikit-learn, sklearn .datasets, import load iris. And the way you, well, let's first execute all this. The way you use this load iris to get a data set is to say iris equals to load underscore iris and as frame equals to true. That's because if I don't have as frame true, then the data is not downloaded as a pandas data frame, but we're used to pandas, so I want it to be a pandas data frame. Okay, so now let's print iris description. So iris itself is something called the scikit-learn bunch format, which has a lot of different things, and one of them is it has the description of what kind of data set this is. So if you do that, you'll see that this is a famous iris database first used by Sir R.A. Fisher of England. So it's actually quite old, and it's a classical one. Let's see, this is from the paper 1936. So it's a very old but famous data set. And basically what it has is it has the measurements of the sepal length, sepal width, petal width for 3 classes of iris flowers. There's a setosa, versicolor, and virginica. And notice that the color here is spelled in English style because the data set is from England. All right, so with this, let's try to prepare the data frame. So we're going to say df equals to iris.frame. And this is the data frame part of the iris. And you can check that you've correctly downloaded the data set by looking at the data frame head. Now this looks more familiar, right? And let's rename the columns because I don't like to type all that. So let's see what's the column names. It should be columns. And the df.columns is this one, and we will rename the df.columns as, instead of sepal length, I'll just name it as SL, SW, and then PL, PW, but I'll leave the target as target. So those will be the column names. And in order to see what the data is like, because if the data is not linearly classifiable, then the multinomial logistic regression that we want to use is not going to be very effective. So let me first set aside the 3 classes. So if you look at the target, you see a bunch of them having zeros. Having zeros means it's the setosa flower. So let's see, setosa will be, because this is the data frame, we use the usual way to select only the special items in the data frame. So we want to look at the target. If the target says 0, those will be what we call setosa. And versicolor would be df target, and this time it should be 1. And virginica is df target and then should be equal to 2. Let's execute this. Oh, something's not right. Oh, this should be this. Okay, and then now we can plot these things. So we're going to do plt.scatter. Let's plot setosa, and I'm going to use the x-axis as the sepal length value, SL, and I'm going to use the y-coordinates as setosa sepal width, and we will say color equals to blue. Now, see, we have color spelled like the English way here, but then that's just the data set, and the correct one is color without the U here, so be careful. And then, oh, I didn't mean to plot it. Okay, so I'm going to plot the other ones. I'm just going to copy this to the next line, the next line. The next ones will be versicolor. And let's use red for that one. And the last one would be Virginica. And the color will be green. Okay, so let's see how the distribution looks like. All right, so it looks like the setosa variant is clearly distinguished from the other group, even with a line, so that's nice. But the versicolor and the Virginica variants are somewhat mixed, and it will be hard to draw a boundary there. But that's just two axes, the sepal length and sepal width. Maybe if you look at the petal, they might be more distinguished. So let's just go ahead and plot the petal length and petal width as well. So I'm going to use P for every one of these instead of the S. And this time, it's a lot better. There seems to be some boundary here which doesn't perfectly distinguish the two, but it will classify correctly probably about 90% of the time. So that's good. So it seems like our data set that we just loaded seems to be easily classified with the multinomial linear regression. Okay, so let's load up the multilinear linear regression. Oh, but before that, we have to first split the test and training set and the test set. So from sklearn dot model underscore selection import train test split, and we use it by saying train comma test equals the train test split, and then we can split the data frame that we have into a train set and a test set, and we want the test size to be 0.2. And once that's split, now we have to pick the x and y. So train x will be train. Now, this train test split returns the data frame, so you select the columns just like you do in a data frame. So we want the separate length, separate width, petal length, petal width, and then train y would be, it's just a single column, so we don't need the double bracket. It's just a single bracket with target. And we're going to do the same thing for the test. So we just change this to test, test, and test. Okay, so we have our training and test sets ready. Now let's start doing the logistic regression. So from sklearn dot linear model import logistic regression, and we're going to say LR is now going to be trained on the training set. So it's a logistic regression thing. And last time we needed something like max iteration equals to 1000, right? So let's just to be sure that our machine is well trained, we'll put as 1000. If I don't put that, it stops at 100 iterations. And now the multi-class, and we're going to select multinomial. Now I briefly explained that there are two other ways. So there's the OVR, one versus the rest, or OVO, one versus one. But since we devoted the most time in the multinomial case, let's take the multinomial one, and that will fit the train X with train Y. Okay, let's run this thing. Okay, that was really quick. Okay, now let's see whether this was done well. So we're going to use some metrics, sklearn.metrics, import confusion matrix, precision, recall, F-score, support. So that was one of the packages that we used last time, but today I want to show you something else. There's also something called classification report, which I found to be quite nice, especially if you have many classes. So we're going to use these two. Let's load them up, and we're going to look at the confusion matrix, and we want to compare the test, the actual y values versus the prediction, lr.predict, of the test x, and see how well the machine learning is doing it. Okay, that's splendid, because 8, 11, 10 are the ones that are correctly classified out of the 30. Only 1 out of 30 is misclassified, so that's very good. Let's also print the classification report. And it's test y, comma, lr.predict, test x. Okay, so the only thing is the classification report has some line changes and all these different string elements. So if you just run it, it's going to not look so pretty. You have to print it to make it look pretty. So if I print it, it does give you the same precision, recall, and F1 score like the other package called precision recall F-score support, but it's organized in a much better way. So I think this is a better one to use.